Am I audible to you? Yeah, let me share the screen. My screen is visible. I hope you can see my screen, the PowerPoint slides. So, yeah. So we'll start today's live session. This is the first live session because of some issues and some interruptions. We couldn't continue on the Saturday, and today we are uh, here for the live session one. So uh, here if you have any discussion you want to do, we can also discuss about that. Along with that, I hope that you have already finished the first week all the classes. There were 3 lectures from professor and one the practical lesson, and there was week one assignment also along with that. So today we are going to discuss about some basic numerical problems, not only numerical but also the technical, or we can say that some fundamental problems we are going to discuss here. After that we'll move next. If you have any doubts we can discuss about that. So let me check recording is going on or not. Yeah, so it's fine now, it's working. Hmm. And I hope that you can see my slides clearly. Let's move to the slide question answer session. First slide. Yeah. So the first question is, which of the following characterizes the ray nature of light? As you know that we have already discussed about, the professor has already discussed about all the characteristic nature of the ray, the photons or light in uh, uh, ray nature, and then he has discussed also about the uh, electromagnetic wave nature and wave nature, and then electromagnetic radiation, and then last one is the quantum photonics, absorption, emission, those quanta things. So I think you have already gone through. So here we are starting one by one, point by point. What are the characterizations he has taught, and we are going to discuss about the fundamental things. So this question, the options are given here that light exhibits properties such as diffraction and interference. Okay. Then the second option is light travels in straight line and casts a shadow of opaque objects that it counters. Then the third option is light can exhibit a state of polarization such as linear, circular, elliptical. And the last one is light experiences a change in direction when passing from one medium to another. So you need to give the answer and wait for some time, then we'll discuss about the answer. Would you like to okay, what is there? Okay, We'll go one by one questions and we'll solve the questions and provide the answer. Then we'll see how the assessment is going for you. It's like a training session. So here two options, option B and D are correct. So why it is, as you know that the ray nature of light follows the straight line. So it has the light traveling in a straight line, and also it casts a shadow of opaque objects because it will not the object will reflect or scatter the light from the surface itself. So it is having the shadow. So this is the one of the correct characterization of the real nature of light, and it is a day-to-day daily example of life. We see our shadow, and that's how we are using so many. Yeah, so that's how we are seeing here the ray nature of light. Then the option D, which is the light experiences a change in direction when passing from one medium to another. It is also one of the example of the ray nature of light, where we see that reflection, refraction, diffraction, all these things are coming into the picture when we are talking about the ray nature of light. Then the why the option A is correct here, that the incorrect is because since the diffraction and the interference can only be I think I told diffraction also for the ray nature, that is not correct. So the incorrect is because of diffraction and interference can only be explained when the light considered as wave. So as professor had discussed in his classes, that the ray nature, it is the electromagnetic or light's characteristics, then it comes under the wave nature, then it also of electromagnetic wave nature also it of overlap with the wave and ray natures. Similarly, the quanta absorption, all these things will be in this nature of light. So moving towards this option C, why it is so incorrect? So it is because the polarization is required. We need to have the electromagnetic wave nature of light. So that's why this polarization and diffraction and interference can't be explained with the ray nature of light. So it's a fundamental but very strong phenomena, ray nature of light. Moving toward the next question, the following phenomena 1 to 4 may be explained by considering light as. So there are XYZW, which is ray, wave, electromagnetic wave, and photons. Then you need to match these followings with the 1, 2, 3, 4. Can you try this? What could be the answer? I think this is the easiest question which I have kept here. Since it is a first week, so I have kept the question levels to the moderate to low. So as we discuss about the ray we are discussing about what? We would usually discuss about the total internal reflection, because we only discuss reflection and refraction in rays. In wave nature, what comes into the picture? As we have already discussed that the diffraction is the part of the wave behavior of the light, diffraction and interference. Then the electromagnetic waves, when the light is considered as electromagnetic waves, what it does, it has the it focuses on the polarization phenomena. Then the last one is photon. As you know that the photon is photoelectric effect will comes into the picture. Okay, moving towards the question number 3. Which of the following statements is false regarding the speed of light? So the correct answer, I forgot to mention here. Correct answer, as we mentioned this one, y3 z1 w2, and this is the correct answer. Question number 3. Which of the following statement is false? Now we are on the question number 3. Which of the question, which of the following statement is false regarding the speed of light? So option 1 is that the speed of light depends on the medium it travels through. Then option 2, the speed of light is faster in denser medium compared to less denser medium. Option 3, the speed of light is faster in vacuum compared to other media. And the last option is the speed of light is constant in vacuum. So which is the fast regarding the speed of light here? Could you please answer it? I think this is a very basic fundamental question. So we can say that the option of this option B is the incorrect answer, which shows that the false statement. Why it is false statement? Because the speed of light is faster than denser medium compared to the less denser medium, which is incorrect. Usually the speed of light in vacuum is c, and if you're comparing the speed of light in any medium, it becomes c by n, refractive index. So when the refractive index is higher, medium is denser, usually n is directly proportional to the density, and that's why this becomes speed of light becomes slower in denser, and speed of light will be faster in rarer medium where the refractive index is less. Okay, so as you can understand the basic thing, the speed of light will be decreasing with the refractive index increasing, and the speed of light will increase if the refractive index is decreasing. So that's why the false statement is this option B. Okay. Okay, so let me check. Yeah. So as I mentioned that the speed light depends on the I think it's visible from backside. So The speed of light in faster is faster in the denser medium compared to the less dense medium. This is the correct answer. And the speed of light does depend on the medium it travels through. It can vary in different materials as per their refractive indices. As I mentioned you, the speed of light is slower in denser medium, not faster. The speed of light is fastest in vacuum, where it travels at constant speed of approximately 2.99 lakhs, 2.99 into 10 to the power 8 meter per second something. Only the statement the speed of light is faster in denser medium compared to the less denser medium is false. Now moving towards the next question. Let's see. Question number 4. A beam of light traveling through air strikes a flat glass slab at an angle of 50 degrees. The refractive index of the glass is 1.55. At what angle with respect to the normal does the ray exit through the glass? So you need to just understand that there are only two things has been given here. One is that the angle of the striking the light on the flat glass slab, which is 50 degree. You can see here, and the refractive index of the glass 1.55. As you know that already the gas refractive index or environment refractive index we need to consider as 1. So could you please try to solve it? What could be your answer for this? I hope that you have gone through all the lectures, so you must be having all the information which I'm talking here. So week first is basically for the fundamental. Okay, can you try to answer this one? It's very basic question. You can comment also if you are not comfortable with the communication discussion. I'll just make one example for you. I don't know how it will be. This is the glass slab, and the n here it is 1.55, and here it will be 1, approximately 1, not 1. So let's try to discuss. So I think you already solved, so the answer will be approximately in this range, 32 to 32.5 degree. So how to solve this issue or problem? So as per the above timestamp, which we have discussed already in the lecture, you can see the professor's lecture. To determine the angle at which the ray exits through the glass slab, we can use Snell's law, which relates the angle of incidence and refraction to the refractive index of the media involved. So first is given as the angle of incidence theta 1, which is 50 degree, and refractive index of the glass is n2, which is n2, and here it is n1, which is approximately 1 we are seeing. I'm sorry for my writing, this screen I'm writing, so not able to write properly. So as we know that, let's denote the angle of refraction as theta 2. So what will happen? The Snell's law states n1 sine theta 1 is equal to n2 sine theta 2. So since the light is traveling through the air, which is n1 is equal to, as we need to consider the refractive index approximately 1. So plugging all the values, n1 which is 1, and theta 1 which is 50-degree incident angle, and the refractive index of glass 1.55, and then theta 2 will come. And so by solving this, we'll get 32.36, which is in the range of this 30 degree to 32.5, 32 degree to 32.5. Moving towards the final uh, understanding that just they have asked the 50-degree and then theta and then incident angle. Sorry, this is your normal and how much it is bent. So 50-degree it was, and now it became 32.36. A second here, 32.36 degree. Okay, now we have common data for question 5 and question 6. So an optical fiber has a numerical aperture of 0.45 and a core refractive index n1 is it's 1.46. So they have asked the question number 5, the determine the cladding refractive index. So you have numerical aperture, 0.45, and you have refractive index of the core, which is 1.46. You need to define the determine the cladding refractive index. Usually you can say that n2. Can you try this question and solve it? Very basic question, and might be you can solve this quickly. So you need to just remember the numerical aperture equation, and then you can solve it. Can you try? Pujita and Alina, try to solve it. It will be useful for you. I think we should go for the discussion. You can see the answer will be approximately 1.2 to 1.5. Why we have given this much range? So the n2 is exactly 1.38. It was less. So how we can calculate this? You know that numerical aperture equation. I'm sorry. This NA is equal to under root n1 square minus n2 square. So we have n1 and na. So according to that, we can calculate the n2 for this. Understood? Are you getting this? Am I audible first of all? Can you just say a yes, no? Yeah. Is it clear or I should be more louder? Yeah, nice. So, the way that's the way we need to solve this question, and this is how the main exam questions also will be asked. So they will give just two values or three values, and you need to determine one more value or two more values. You will see. Now the question number six. Somebody, okay, yeah. I think the as you know that the question number 5 and 6 has the same common data. An optical fiber has a numerical aperture of 0.45 and a core refractive index N1 of 1.46. So you need to remember this thing, this common data thing, and you need to solve the question number 6. Which of the following properties, could you please mute it, Mamatha? Which of the following properties of an optical fiber are desirable when designing for an endoscopic application? So, what should be the desirable things? Please mute it, Mamta. Can you answer it? Sujita, Alina, could you please answer it? Aperture. You can say ABC or something. That is better. ABCD. I can understand. ABCD. Pi and A. Okay, correct. Last reading area is required. Okay. High numerical aperture and higher refractive index in the core than in cladding. Obviously. To confine the light, we need to have high numerical aperture. And numerical aperture, obviously, you know. Yeah. Yeah. So obviously, this is the correct statement. And this also higher refractive index in the core medium than cladding. You know that the numerical aperture is depends on the contrast of the N1, which is cladding. So obviously it should be higher refractive index. Then only the numerical aperture will be positive. And numerical aperture can't be negative. So this is the correct answer. These two. Okay. Okay. Next question. Yeah. So higher refractive index in the core medium than the cladding and higher numerical aperture as we discuss about these things. You want to read? Just you can read for a few seconds. I think this is a very fundamental class which was taken in the week one. So you can understand because it's already we have discussed so many things. We have understand so many things in the class 12 itself or maybe in BSc, BTech. Okay. So now the question number 7. In the question given below, there are two statements marked as assertion A and reason R1 and R2. Mark your answer as per the codes provided below. Assertion A is given as a double slit experiment is set up with a monochromatic light source. When the distance between the slit is decreased, the observed interference pattern on a screen becomes wider and the fringes become less distinct. Reason 1 R1. Large spectrum of light results in the reduction of the fringes contrast. Reason 2 is there. The angular separation between the fringes is inversely proportional to the distance between the slits. Could you please answer it? What do you think about the assertion first of all? Double slit experiment, and then monochromatic light source, then the distance between the slit decrease, then the observed interference pattern on screen becomes wider. Is it true? Is it correct? And the fringes becomes distinct, less distinct. True. So what about the reasons? Which option you are thinking? Option A, B, C, D, or 2 is correct. Alina or Mamta, do you want to comment it? Something? Just you can guess. Okay, yes. So which option you are saying? A or B? Which one? A, B, C, D, B. Okay, let's move to the answer. So a monochromatic light source does not represent a large spectrum of light, as you understood previously. We have discussed about monochromatic light, and here it is discussed about the large spectrum of the light, which is contradicting each other. So contradiction itself says that the R1 is false. Then in a double slit experiment, interference experiment, the angular separation between adjacent fringes can be calculated using the formula del theta is equal to lambda by d, where del theta is the angular separation between the adjacent fringes, lambda is the wavelength of the light, and d is the distance between the slit. When the distance between the slit d is decreased, the angular separation between fringes theta increases. This can be derived from the formula mentioned above. Since the angular width of each fringes is directly proportional to the del theta, the larger angular separation results in the wider fringes. So as you have mentioned, the option B is the correct answer here. Okay. Then, therefore, when the distance between the slit is decreased, the interference pattern becomes wider and the fringes become less distinct. Okay. I'll give you some more problems regarding this. Now we'll go to the next question, and then we'll come to the one by one. We'll come for the um, again for the discussion. Okay, so the question number 8 here: a glass prism is used to disperse a beam of light consisting of two wavelengths, 650 nanometer and 520 nanometer. The refractive index of the glass prism for these wavelengths are 1.52 and 1.56 respectively. The normals with respect to the entering and the exiting rays in the prism interact at an angle of 165 degree. Calculate the angular dispersion produced by the prism, and you need to note that angular dispersion quantifies the angular difference between the emerging rays of different wavelengths. You need to understand first this one. Okay, angular difference. Could you try to solve it? Draw a prism, try to understand it. Is it possible? Option B. There is no option A. Okay, you're saying about the previous question. Is it understandable or should I explain you? You want to try? Okay, let's try this answer. So answer will come approximately 0.5 to 0.7. I'm giving window because it might be human error which can lead to the okay. Okay, is it possible now? Okay, so the refractive index of lambda 1 is n1, which is 1.52, and the refractive index of lambda 2 is n2, which is 1.56. Wavelength of light lambda 1 is 650 nanometer, and wavelength of light lambda 2 is 520 nanometer. Okay, so the wavelength of light, sorry, the A is the apex angle of the okay. This is your A, and if you have A, then you will get easily all the informations. So as it is mentioned that the prism intersects the existing ray in the prism intersects at the angle of 165. It means that the A we can calculate by subtracting it from 180 degree 165, and you will get 15. A this angle will get 15 degree. So it means this can be used for the getting the angular dispersion. So how much difference will be there? Suppose you're having one wavelength like this, 650 is coming like this, and it's moving in this way. But it's the similar way. Let me change the color of the color. 520, almost cyan color, cyan green color. This is also going the same way, but here the diffraction will be more, dispersion will be more here. So dispersion is more, so this gap we need to find out the gap between both the rays. So it is coming into it's approximately 0.6. How it came? So you need to go through the lecture. You will understand that how we can calculate the A. It's very easy. Then after that, how to keep all these values in the del T. So dispersion del theta is equal to n1 n2 minus n1 A. Angle can't be negative, so usually the higher refractive index we need to keep first. So according to this, we'll get you need to multiply with 15. So 1.56 as is mentioned here. You don't need to write it this way. This you can follow. Okay. So you'll get the 0.6 degree of the angular dispersion by the prism. Understood? Suppose you have the apex angle of 30 degree, then what could be the answer? So you need to just change this value and you will get the value here 1.2 degree, which is use. It may be possible you can go up to more 60 degree also if you have all the angles of the prism is 60 60 60, so 120 180 180. So you'll get the maximum of 2.4 degree of angular dispersion. Okay, moving towards the next question, which is having the common data of question number 9 and 10. So the common data is Young's double slit experiment. A screen is placed 1 meter away from the double slit aperture. The distance between the central fringe, bright fringe at the center, and the first bright fringe, first maxima, is measured to be 2 centimeter on the screen. So you have given the double slit experiment setup. Okay, let's see, this is your two opening, this one and this one. So you are getting, your screen is this much far, which is 1 meter, and you have the first the center uh, bright fringe at the center. So I'm not able to make it properly, and you have the first maxima here. These are the first maxima. So it is mentioned that this place to this place, the distance is 2 centimeter. Now you need to think about the question. Question 9. If the wavelength of the incident light is 600 nanometer, the width of the each slit, assuming that both of them are equal size in millimeter. So you need to um, find the slit uh, size for both. Okay, so in mm, how you can find it out? Can you try to answer it? You need to think about the lambda, which is 600 nanometer. Everything has been given here. You just need to put all this thing. This is the orange light. Need 0.015 mm. Let's see, 0.015. I think you are so close. Not. Yeah. Anything you want to say? The answer will be between 0.02 to 0.04. Now you check once. Yours is little bit less. So the numerical question will give window, Q's window, 0.02 to 0.04. It is very high. Could you please try now again? Okay, let's see the answer. So in Young's double slit experiment, the slit width D can be calculated using the equation. Anything? Somebody wants to join? Okay. So D is the slit width, and we already knew that the slit width is equal to M lambda d, capital D by W. So D is the slit width, M is the order of the fringes. So we are talking about here the um, first maxima from the uh, central fringe. Okay, so first maxima is M is equal to 1, and the lambda of the wavelength is lambda is the wavelength of the light, so which is also given here, 600 nanometer. Then D is the distance between the screen and the slit, 1 meter already has been given, and the W is the distance between the central fringe and the first bright fringe on the screen. Now, suppose you are substituting the given values. So what will happen? You will get in nanometers, so we need to convert into the meter, the lambda value, and D is already given in meter, but W is given in centimeters, so we need to again convert into meter. And after calculating the slit width, uh, after keeping all the values in meter in the equation, this equation, we will get the slit width. Slit width will be 0.03 mm. Could you check what was the wrong with your answer? Was that the 0.015? Means something you have missed while calculating, maybe. Yeah, calculation error. Otherwise, your answer was almost correct. Maybe you forget to multiplication with 2 or something. Hmm. Okay. Okay, then moving towards the next question, which is question number 10. Already we have discussed that the common data is there already, which is the in Young's double slit experiment, a screen is placed 1 meter away from the double slit aperture operators. Second. And the distance between the central fringe to the first maxima is 2 centimeter. So this thing you need to understand. You need to remember. Then you need to go to the question number 10. The angular position of the first bright fringe is in radian. You need to say radians. Could you please answer it? I think you need to calculate this one. The second. I can't make it the straight line. You need to just answer that the angular position of the first bright fringe from the slit. Could you answer it? It's quite easy. I mean, you can just do. You need to remember all the equations which has been taught in the class. So most of the questions will be like this way. It has been given that the common data, and you will be asked 2 3 questions together simultaneously. Sometimes it will be asked like question number 9's answer, whatever answer is coming, which will be used in the question number 10 also. So you need to understand all these things. So if one question is wrong or one answer is wrong for the first question, might be it will affect the second question of the common data question. Have you tried this? Have you okay 0.02? Have you worked on the week one's assignment questions? How it was? It was moderate or hard, or it was okay only? Or you were going to attempt it? You didn't attempt till now. Okay, let's see the question's answer. You have mentioned 0.02. Yeah, it's in the range. Yeah. To find the value of theta for the given problem where the lambda is 600 nanometer and d is 0.03 mm, we can substitute these values into the equation theta sine inverse lambda by d. This is also very basic formula and calculate the result. So um, first let's convert the value of the constant unit. We will convert lambda from the nanometer to meter and d from millimeter to meter. Then lambda will become in 10 to the power minus 9 meter, and then d will become also 10 to the power minus 3 meter. Then these values we need to keep in this equation where we'll get in the value the angle. Actually I have written here theta, it should be angular position or angle, so it will be in radian, 0.02 radian. You are correct. It's quite impressive that you have already taken the d from previous answer and then you put all these things. Yeah, moving to now almost it is finished, the question answer things. If you have any doubts you can discuss also. If you want I can also go through this some of the important equations which we can discuss here. I'll give the problems, you need to solve it, and if you are not able to get it, we will solve together. Could you please tell me if any doubts you have in the uh, lectures of first week? Have you gone through all the lectures? I think okay, so I'll give us a basic, I'll ask you a basic question which is for the paraxial approximation. So let me create one slide here. Oh, this is not. Yeah. Um, for the paraxial approximation, you have a lens system. Suppose for the telescope or something, you have a hmm, we can say, I think you have gone through the lectures, so I'll just write the problem directly. So suppose you have one axis this way, and you are seeing something which is here, which is having y2, y1, and you have, this is your rays going like this way. Now, as you know that this is your straight line, this is the axis. Now you have here theta 1, theta 2. Hmm. Hmm. This is T from here to here. Can you okay, so you need to define the theta one, okay, for given value. I'll give you the value, some value, okay. Suppose y2 is something like 1000 meter, then y1 you have 1 centimeter, theta 2 you have 0.2 degree, and d you have 1,10,000. So not 1 lakh, just kilometer. Can you answer this one? What could be the theta one? This is in centimeter. Try to solve it. What could be answer, you see? First you need to, all the units should be in the same uh, unit, same matrix, then you can solve it. Try to solve this question, this problem, then we'll go for the next problem. Is it possible to solve? Okay, try this first. Let's see, and I'll give you the next problem also. Is this right? Okay, I'll give you another problem which you need to solve. You have a numerical aperture, standard actually, this question is quite standard. Numerical aperture of 0.22, and you have theta 1 core refractive index is 1.5. What could be the cladding's refractive index? That also you need to find out. Then I'll give another question. Question 3. Here you have the apex angle of 20 degree, and as you know that each wavelength has different refractive indices. So for n, green, for example, this is for the water. So n green 1.335, and n red, the refractive index for the red wavelength is 1.33. Okay, so now you need to calculate the uh, the dispersion angle. Yeah, so you need to calculate the d del g d del, which is del green minus del red. How much the dispersion is an angle. Now okay, so these two questions, and first question I already given to you. I don't know, I'm not able to write in the straight screen, so are you able to understand or not? Yeah, it's not able to. Yes. Yeah, something. Then question number 4. First you try this, step by step will go. Let's try this. We can comment also answers quickly. This is how the question will come in your assignment, also in the main exam. Please answer it. At least try the question number 2. You guys should try something questions, basic questions. I'll also give little moderate questions also if you want. Question number 4 I am giving you. This is related to question number 2 only. Suppose you have 4, refractive index is 1.5, and you have cladding refractive index is approximately 1, like air. Then what will be the Na, numerical aperture? You need to calculate. Try these three. Pujita, Veer, Joy, please try. Abir, Janni, could you please try? I think it's very easy questions. These are very easy questions. You can see here, numerical aperture equation is, anybody answered? Yeah, question number 4, 0.5. 0.5. Can you cross check once? 3. Okay, let me see. What about the question number 2 then? You are not able to do that? Jay, the question number 2, I think you have done some mistake here. You need to understand this one. Na is equal to, we know that, root n1 square minus n2 square. Try now this equation. Let's see. — 1.484. Question, which question? Question 4? Oh, question 2. Okay. So you're saying 1 point, let me check here. Yeah. N1 minus N2. So as we have already discussed that N2, if you are taking, then it will become, oh sorry, here square I forgot. So it will become N1 square minus N square. This is the way. Similarly here also. So 1.11, yeah, now it is correct. 1.11. Here it will be 1, 2, 3. What about the question 3? 1.48. 1.484. Yeah, correct. This is sorry, 1.484. Yeah, 0.1. Are you sure about this? 0.1? Hmm. Which is n green minus n red. A. How much is coming? 0.1. Yeah, 20 degrees there. Yeah, 0.1. 0.1, so it will become 0.1. Yeah, you are correct. So question 3 also correct. What about the question 1? Did you try? Just keep all the values, no? Are you able to understand the question? I have asked you, this is the theta one actually. I don't know how I wrote this one. It's not maybe here. Theta one you need to calculate. If the RI is same, this the angle is same. Which one? You're talking about the question one? It's a optics problem. Yeah, it's a optics problem. There will be so many optics here, lenses and other things. So you need to just the I think you understood what I'm saying here. I'll just give you the answer. Not answer actually, the equation. So this can be this is the best way I can say. You need to solve this problem. So it's easy. Just theta 2 is equal to theta 1. So you don't need to think so much about this. Already I asked theta 1. You could answer like this, maybe 0.2 degree. Got it? I didn't ask about the theta 2 and other thing, no? Y2. No, not about y2 and y1. Yeah, so that's the thing. Now, any other things I'm asking? Okay, I have one problem. which is this one. We have discussed about the, not this one, this one. The first fringe, bright fringe, is 2 centimeter. Okay. Suppose we have at second, here itself I'll just edit it. Bright fringe at 3 centimeter. Just forget about this value now. I just change it to second, and here 3 centimeter. What could be the answer here then now? This is second. This is second. Something like this. So from here to here, this is the distance is 3 centimeter. Now you solve this question. Everything is same apart from that. Zero 0.04. Let's see. Okay, so m is equal to here 2. Then what else will change here? D will change, W will change 3. Then this will become 3, and m will become 2. Now effect. What will be the answer here? For a while, just forget this value. This value forget for a while. Calculate it. Is it correct? 0.04. Are you sure 0.04? It's not. Let me try 1200. Yeah, you're correct. Divide by 3. 400. Yeah. So it will be 0.04. Let's see. So it will become 40, and then this will become 0.04 mm. Okay. Yes, correct. Then what could be the answer for this one? Angular position will change. The second, because we are discussing about this second now. 0.03 radian. Hmm. Yeah, after keeping all those values, might be you understood already. So this will become your 0.04 mm, then or this one here 0.04 mm, then it will be 0. Yeah, 1.5. So it will be double. You are correct. So it will come first will come with 0.015. You need to multiply because m is equal to 2. So it will become 0.03 radians. Yeah. Now, okay, so I think enough for today. We'll discuss. You want to discuss more? Anything you have in doubts? Whatever I discussed today, it was understandable, or not here? This one. This one. Was this understandable? Can you try this question also? It is already given here. 32.36 degree. Yeah. So you want to ask any question, doubts you have? Could you please ask? Even if you have doubts in the problem solving assignment or something, I can help you. Deadline is over or not? The submission problem solving session. Can you conduct class like this in future for problem solving? Yes, obviously on Saturday, every Saturday it will be there. 4 to 6. Each week will be there. And I feel like mm, today I could have taken some more discussion compared to the question answer only. So next time I'll try to include some discussion also about the problems which professor already discussed in the classes. So in basic understanding we can go, and after that we'll solve question answers. Is it okay for you, Joy, and others? Yeah. Every week it will be there. Any questions, any problems, you can ask anytime. You don't need to be hesitated or something, because this is for you only. This is given. This live sessions are free for you. You can join every week and discussion involved in discussions. Gather more and more people and have nice discussion about the concepts, question answers, problems. The course is not only for the question answers, it's for the understanding. So it should be useful for you in future when you are writing exam. You can practice here n number of times. So there will be most probably 12 to 13 live sessions in this course. So each week it will be. Today is the first one. Next week it will be from Saturday onward. So each Saturday 4 to 6 we will discuss all the questions, doubts, only things. So don't be hesitate. It's for you. You need to learn. You need to understand. So this is given for you free of cost, everything. And if you want to write the examination, I think there will be a minimum fee something. I'm not aware about it, but I think you need to pay something for that. Apart from that, the course is free of cost. Okay, understood? I'm not able to see the, let me see here, the assignment date, last date. According to that, I can solve some questions, assignment questions. If it is date is not over, then I can't now. Deadline, I don't know where is it. Feedback assignment. Okay, so it is already up to 5 of August. So I can't solve now any questions. We'll see next time. Oh, this are almost. Okay. Already we have solved this question answers. I didn't know that. Okay then. We'll meet next week, Saturday. Not next week. This week itself, the second live session, and we'll discuss more and more questions. Okay. Do you have any doubts? You can ask. I am here live for some time. Uh, it will be like 24 minutes there. So I can be here. If you have any doubts, you can ask me. I just want to clear one thing that the today's session was fully for the ray optics, not for the only few questions where there was a wave optics, like a question 9, 10, but mostly the ray optics we have solved. So we have not gone to the through to up to polarization or intensity, phase, those things. So it will come one by one. Anyone, please, any doubts? Can you please ask? Any problems you have regarding the questions, or any questions you have? Anything? Arsini, please ask any questions you have. Already live session, already we have discussed so many questions, almost more than 20 questions. You can also see the live sessions recording will be available on the YouTube. Meanwhile, if you have any doubt, specific doubts, you can ask me. And please join every week live session from Saturday to Saturday on Saturday, weekly Saturday on from 4 p.m. to 6 p.m. afternoon time. So they will discuss so many questions and also concepts.